So my name is Kim Green. I'm the secretary / program coordinator for the Mount Cuba Observatory. We are going to have Rob Lancaster, who is the president of the Delaware Astronomical Society, who's going to be hosting the program this evening. And with that, Rob, I'm going to go ahead and hand it over to you.
Okay, sorry. So I'm Rob Lancaster, if you didn't know. I'm president of the Delaware Astronomical Society. And what I'm going to be presenting tonight is about how to get started in amateur astronomy. So this talk is geared a little more towards beginners, but hopefully there's some things here for more advanced people as well. And of course, when we get to some of the things, you might want to know a little more about it, and I can go a little more in depth when necessary. All right, I'd like to start off with a little video. I won't show too much of it because it's probably going to be a little bit choppy over Zoom. But what I want you to see here is how amazing the night sky can be. So what you're seeing there is a video that was shot with a camera, kind of like this one. And it's basically a series of images that the person took, one after the next after the next. And then they combined it all together into a movie. This is something that you can do yourself if you get so inclined. Something I haven't done yet, but I'd like to do in the future sometime when I have a nice, clear, dark sky at a star party or some other event like that. If you don't notice, there's some red lights over here, and there's what looks like some objects set up out here. That's because this is at a star party. It's an event you can go to where a bunch of people are observing the night sky, and they bring their telescopes and they go out camping and they have a bunch of fun at a really dark site. And so there's a couple of things in that video that I thought were pretty helpful. Not only is it cool stuff that you can actually see outside, it's also something you can do and something you can go to. But to get you started in amateur astronomy, you don't need a lot of expensive equipment. You just need your eyes. And what I'm going to do to start off, I'm going to go through a series of different things that you can see without any kind of equipment. You won't need binoculars necessarily. You won't need like a telescope like this, or you won't need a camera to see any of the things I'm about to show you. And I'll talk a little bit about them real quick. So first of all, the sun and the moon, most people are very familiar with that. Of course, the moon goes through different phases, so it's not always the same thing you're seeing. You often see different sides of the moon as the phases change, so you can see different patterns, you can see different things at different times. Also, whenever you have a lunar eclipse, it looks very different. And you can see this reddish color with your eye. It's actually quite pretty, but that's a little more rare. Another thing that you can sometimes see is a solar eclipse. And that happens much more rarely, but we have two of them, one that just happened in 2017 and another one that's going to happen very soon in 2024. So hopefully you can prepare for that and get ready and travel to wherever you'd like to go to see that. But it is really beautiful. It's something really cool that you can see. Of course, if you want to see a view like this, you do need a pair of binoculars and you do need solar filters on those binoculars, or it wouldn't be safe to look at like this. But it does look like that with your eye. All right, next item. The planets are also something you can see just with your eye. They aren't going to look like a whole lot. They'll look like a really bright star, kind of like this. So here is a cluster of stars in the sky that you can see with your eyes, called the Pleiades. The Seven Sisters is another name for that. And this is a planet right amongst the Pleiades at that time. The planets move just like the moon and the star, just like the moon and the sun do in the sky as time goes by. So, you'll see that the sky goes over your head over the course of the night as the Earth turns, but the planets and the sun and the moon, they all change positions differently than the stars. So they travel in front of the stars. That's actually why planets got their name. Planet means wanderer in Greek. So they named the planets because they were wanderers in the sky. Now, another thing that you can do, which is actually very good for beginners to do, is to learn the constellations. There's a lot of interesting stories associated with these from many different cultures, but primarily the Greeks, because they handed down our main constellations to us. But there's a lot of other interesting stories from other cultures about different constellations that they had in the night sky. But learning these patterns isn't just good for learning those interesting stories and recognizing your friend in the sky. It's also kind of nice because once you've figured out these patterns, you recognize what part of the night sky you're looking at. And you can find some of the things that you might want to look at in binoculars or a telescope. You could say something like, oh, well, this here is Cygnus the Swan, and I know that in Cygnus the Swan, approximately right about here, if I look at these stars, makes kind of like a shape here, right about there is an interesting object. In fact, the object I'm pointing at is the Dumbbell Nebula right there. And actually here, this is Lyra the Lyre. And if you look at this little parallelogram shape down here below Vega, there's two stars right here, and about halfway in between them, there's a really small nebula called the Ring Nebula, M57. So if you learn the patterns of the constellations, they'll help you find the objects in the night sky. So it is kind of helpful, not just for people who are interested in the signs of the zodiac, and not just for people who like Greek mythology. It's also a useful tool for an astronomer to use. Another thing that you can't predict, but that very frequently you can see, is a meteor. So a meteor or a shooting star flying through the sky is essentially a rock, some type of particle. It's usually very, very small, like a piece of dust, just flying down through the atmosphere. Sometimes they can hit the ground and become a meteorite, but typically they just burn up in the atmosphere. And when they burn up, they make a beautiful show and sometimes even a sound. Sometimes you can hear them. So when they're coming down, you can't really predict that, except to say that every now and then you'll get a meteor shower, which is when the Earth is traveling through the remains of a comet, where it went through a certain area of the sky and left behind a bunch of bits of rock and dust and ice and all sorts of stuff in its wake. And then they rain down on the Earth when it goes through that wake. So you can predict when there's going to be a meteor shower, but you really can't predict when there's going to be a meteor. You really just have to sit back, get a nice easy chair or nice lounge chair or something, lay back. I have a nice zero gravity chair. It's really comfortable. And I lay back and I look up at the sky, and every now and then you'll see a meteor. This is a photo that I took of a meteor in Colorado, actually. You can see a lake here. This was in Colorado. I think it was Lake Grande. And you can see the meteor falling through the sky in front of the Milky Way. Another thing that you can see sometimes is comets. Oftentimes, though, the comets that we get aren't very bright, and so you often do need a pair of binoculars or a telescope to see them, and they'll just look like a fuzzy blob. But every now and then, we get a big, beautiful comet like this one. This was Comet Hale-Bopp. I took this photo actually in a street. I set my tripod down on the street, put my camera on top of it, and snapped a snapshot of it. I didn't have any fancy equipment. It was just a camera, even cheaper than this one, just sitting on a tripod, and I snapped this photo of Hale-Bopp. And that was in 1997. So every now and then we get lucky and get a really cool comet. We had one this past summer, which is very nice, and hopefully you get more in the future. But they are definitely beautiful to see with your eye. Another thing that anybody can see, and this one is usually very surprising to people, is satellites. So a lot of people think there's no way you could see satellites, but what they do is they reflect the sun's light as it bounces off of them. And if you look at the right hours, anytime from sunset until about 11 o'clock or so, you can look up and just stare at the sky for a while. Let me play this little movie. And, you know, you'll notice that there's a lot of stars up there, but you might see one moving. You notice that it looks just like all the other stars, doesn't look unusual, but it's kind of moving. It might be fast and it might be slow, but that is usually a satellite. The way to tell the difference between satellites and airplanes typically is that the airplanes will blink and they're usually much brighter and they often are blue or red, depending on which side of the airplane is facing you. But satellites usually just a solid white color and it just goes real slow among the other stars. But literally, you can just sit down on any night, lie down on your easy chair, on your blanket, and just look up at the sky and just stare. And literally, probably within 2 or 3 minutes, you'll see one. They're all over the place. We have thousands and thousands and thousands of pieces of space junk up there, and they all reflect sunlight. So that's definitely fun. Another thing that you can see just with your eyes, and I think is truly beautiful, is the Milky Way. But you really need to get to a dark site. So this picture here I took in Colorado again, but you can see it at a site maybe about an hour or two outside of Philadelphia or Wilmington. You just need to get to a dark site and you can see the Milky Way, particularly in the summertime when the center part of the Milky Way here is high in the sky. That's the best time to look. So I would look in, say, August at a really dark site, look in the south, and this is the core of the Milky Way right here. Constellation Sagittarius right here, or the Milky Way is right there. And you can actually see the pattern here. This is the center bulge of the Milky Way, and this is arms stretching out that we are in. But you can take a photo like that too, and I'll tell you how in a few minutes. One thing that's a little more rare would be an Aurora Borealis. I have seen it 5 times in my lifetime, and I often go observing at dark sites, often go to star parties and stuff like that. So it's not very common that you'll see one. But if you get to a really dark site, and if you go further north, you have a good chance of seeing one at some point. This is not my photo that you see here, but the photos that you see here were taken at the same event I was present at. I did see this aurora, and yes, it did look like that to your eye. It was absolutely beautiful. I saw that at Cherry Springs State Park, which is in the northwest of Pennsylvania. And it was spectacular. That was about 20 years ago that I saw that. I have seen it a couple times since then, but it's very rare. You can get a prediction from the Aurora Forecast Center about upcoming auroras, but again, it's very rare. You'll just have to check every now and then. You might see it in the news that there's going to be an aurora. And you can also sign up for aurora alerts. So there's several different ways you can get the information that an aurora might happen. But I can't tell you the number of times that I've heard that an aurora might happen, and then you go out and it's not happening. There's just nothing. And it's very hard to predict. When they see the sun eject matter that streams toward the earth, it might miss the earth entirely. It might run into the earth and not interact with the magnetic field. It might hit the magnetic field and make a beautiful aurora. Maybe the aurora is kind of small and it's not visible all the way this far south, or maybe it's nice. So it is really hard to predict. But if you do hear that there could be one, you definitely should go check it out because, as I said, I've seen it about 5 times and it is worth it. It is definitely beautiful. Another thing that is really cool is the International Space Station. So as opposed to the ones that I talked about before, the satellites that I mentioned earlier, the International Space Station moves a bit faster and it's a lot brighter. And when I say a lot brighter, I mean a lot brighter. You can't miss it. Like it is brighter than an airplane sometimes. Right? So it goes fairly quickly across the sky, and you can use apps on your phone or on the computer to get a prediction of when it's going to pass overhead. It'll tell you to look to the northeast, to the southwest, some direction, and it'll tell you how high it'll go. And it is really neat to watch. And I'll tell you, that's also a really nice object to look at in a telescope and binoculars. But it's really cool to see it just with your eye. And then you can wave up there and say, hello, astronauts, as they go overhead. Now let's talk a little bit about these binoculars that I've showed you several times. So binoculars, people don't usually associate that with astronomy. People usually think telescopes, but binoculars can do quite a bit. If you take a pair of binoculars and point it up at the sky, you can see a lot more stars that you can see with just your eye. So whereas with your eye, they might see a couple stars, when you put these up to your eye, you see hundreds and hundreds, even thousands of stars fill the view, and it's pretty amazing. I really like to take a pair of binoculars and point it at the Milky Way. This is a photo I took of a section of the Milky Way. You can see some nebulas here, as well as some star clusters. And it's really nice to just pan around the Milky Way, just looking at the stars. It's really worth doing. Often when I'm doing astrophotography at some dark site, I'll bring along a pair of binoculars, and while my images are taking and snapping away, I'll just pan around the Milky Way with a pair of binoculars, because it is really nice to do. You can see many things with that. You can see, of course, the planets and the sun and the moon. Sun, if you have a solar filter, of course, got to say that. But you can see nebulas, you can see clusters, you can see galaxies, and it is very pretty. So what can a telescope do for you? Why would you want that instead of binoculars? Well, it shows you a much closer up view, but also a much brighter view of a number of deep sky objects. So if you look at the moon with a pair of binoculars, you start to see the craters, but you really don't see the craters till you get a telescope. And they can be really amazing when you do that. You can see all kinds of details like mountain ranges, and rills and valleys, and craters within craters, and central peak when it got splashed by the crash of a meteor slamming into the moon. It made some of the dirt splash up in the middle. It's really neat to see. But also, you can see some nebulas, you can see some galaxies, and you can see lots of different clusters with your telescope. Now, it's not going to look quite like you see here. Really, most of the time, these objects here will look like a fuzzy blob. This is the Orion Nebula in this picture right here. And you can see all of this detail, except maybe some of this at the edges, but it's going to look blue-green. It's going to look fuzzy, and it's going to look blue-green. It's not going to look as detailed as this. And this galaxy that you see here is called the Andromeda Galaxy. You will see a blob mostly. You're probably not even going to see this darkling here unless you have a really big telescope. And this is the Pleiades again, with the blue reflection nebula behind it. And you're likely to just see the stars. You're highly unlikely to see the actual nebula with your eye. These are all pictures that I took with my telescope. But again, you're not going to see this with your eye. But you definitely can see this. Saturn and its rings and the little gap between the rings. I'll tell you that that is an amazing thing to do with any telescope, is to look at something like Saturn or Jupiter. I can tell you that when people look at Saturn for the first time in the telescope, they look at the front of the telescope to see if we put a picture in front of it, because they're so amazed at how cool it looks, how nice it looks with its rings. So that's definitely something you want to look at with the telescope, if you can. So then most people's first question when they join our club is, what telescope should I buy? Well, that's an interesting question, and I get it all the time. There's lots of different telescopes out there. In a lot of department stores, they talk about these really powerful telescopes. This is actually my first telescope. It was 402 power. Wow, lots of power. It was low prices, it's not that expensive. It did have a really long tube. Not all of them do though. This is a refractor with a fairly short tube, but mine had a pretty long tube, my first one. You also got this type here in the middle, which looks really expensive and is really expensive. It's fancier, it tracks the sky, it has a computer, it'll automatically go to the objects and things like that. And this one on the right here, this is called a Dobsonian telescope. This one, you just shove it to point at whatever you want to look at. The prices are average. They're not too little and not too much, kind of medium prices. The eyepieces are the front of the scope instead of the back, like the other two ones. They're typically not go-to, and they typically don't track the sky. Although if you get a more expensive one, they will. So there's a lot of options. There's a lot of possibilities. So what should you buy and what's important? Well, let's talk about that. First, I want to point out the main point of a telescope. This is what a lot of people miss. A telescope is meant not to make things bigger. A lot of people want to buy a telescope for lots of magnification, huge power. No, 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 no. It's about getting more light into your eye. You know, if you just look with your eye is probably 7 millimeters in diameter. It's not very big. But your telescope is a bit bigger than that. You know, this one here, probably about 3 inches. You can get ones that have 10 inches. You can get ones that have 20. So you can get a much bigger aperture to collect the light. It acts like a big bucket, just collecting all the light you can and shoving it in your eye. And that makes things much, much brighter. And it makes it possible for you to see things like nebulas and galaxies that aren't actually that small. They're just really dim. So bigger aperture is better. That is a plus. But I'll tell you, if it gets a little too big, you can't fit it in your car anymore. So like this scope right here, I can pick it up with my hand. The one that I took those pictures with that you saw a minute ago, I'll need both hands. And if you want to get a research grade scope, you'll need a crane. So, you know, there's a limit to how big of a scope you actually want to get so that you can actually use it. You got to be able to fit it in your car. You got to be able to lift it, get it to where you want to observe. So they say that the best scope is the one that you would actually use, not necessarily the one that'll give you the best view. So another thing is the focal length. That's another very important thing. The focal length is essentially how far it is from the optical element to where the light comes to focus. So here is a longer focal length. Here is a shorter focal length. You can get different lenses that have different focal lengths. Like I mentioned a minute ago, this scope that I have here has a very short focal length, you know, that long. My old one that I had first, one that I got when I was a kid, had a focal length this long, all right? Real long. You can't even see my arm, can you? Okay, well, really long, really big. But the point is that you can get different focal lengths. If you want a bright view and a really wide view, then you want a shorter focal length. If you want a very close-up view, very focused, very zoomed in on the object, then you want a longer focal length. And depending on what you want to do with the telescope, you want a different telescope for the purpose. So like this telescope that I've been showing you here is really quite good at getting big, wide nebulas or galaxies. It's really great for scanning the Milky Way, looking around at all the different things that are in there. If you just want to look at Jupiter or craters or Saturn, then a longer focal length might actually be better. But if you want to scan around the Milky Way looking at nebulas, a shorter focal length might be better. Here's a different type of telescope showing the same thing. This is a mirror reflecting the light and focusing it to a point. Just like the lens, the focal length is what matters here, not necessarily the type of optical element. So let's talk about the different types of telescopes now, because there's really 3 basic designs. You've got the first one, which is a refractor, like the one I've been holding here, which just has a lens in the front and an eyepiece that you put in the back. So the lens focuses the light, and then you magnify it with the eyepiece at the back so you can see the view. Then you have a reflector, like this one here, which is like the Dobsonian I showed you in the previous picture. If you don't remember, looked like this. So what that does is the light comes into the tube, it hits a curved mirror, and that focuses the light up here, and there's a little mirror here to knock it out the side so you can put your eyepiece in and see it. And then the other type is more complicated optics like catadioptric, Schmidt-Cassegrain, Ritchie-Chrétien, and many different types. But they have multiple optics in different places to try and shorten the tube, and it gets very expensive. So for a beginner, what I would usually recommend is actually the one in the middle. You'll get the best bang for your buck, and it's probably about the easiest one to use because you can just shove it and push it at what you'd like to look at. It's very easy to push to the object you'd like to see. Whereas this one, you're going to have a lot more trouble setting it up and getting it ready to use than is worth. I mean, it's nice to have go-to capability to say, go to the Orion Nebula, and then it swings over and goes to the Orion Nebula. But it takes a lot to get it there. And so I would personally recommend something more like this. It'll save you money and you'll use it more. And you'll have more fun with it. At least that's my opinion. I usually don't recommend the one on the left here, unless you're going to a really dark site and panning around the Milky Way, or you're just looking at the moon or Jupiter or Saturn. If you want to see the really cool deep sky objects, like the galaxies and nebulae that I was mentioning earlier, you want something more like this. I want to talk really quickly about eyepieces. So I mentioned earlier that your eyepiece magnifies the view that your telescope has focused, the image that it has produced. It makes it bigger so you can see it better. So different eyepieces with the same telescope can give you different magnifications. So you buy your telescope, it's this focal length, and then you get an eyepiece, and you get another eyepiece, and you get another eyepiece, and each one of them will give you a different view. So if you want to look at something like a planet, you might use a higher magnification or a smaller focal length eyepiece. If you would like to look at something like the Andromeda Galaxy, which is big and wide, then you'd want a longer focal length, a smaller magnification. So again, yes, I said that a longer focal length eyepiece will give you a smaller magnification. Smaller focal length eyepiece gives you a bigger magnification. Because to calculate this, you just need to divide the focal length of the telescope by the focal length of the eyepiece. So if you did 1900 divided by 32, you should get 59. Okay, so it's a really quick and easy way to figure out how much magnification you'll get with a particular eyepiece. And usually I'd recommend at least 2 eyepieces, one that's zoomed in, one that's far out, and you can get more as you like. But probably one that's like 32 or 26 somewhere up here, probably one somewhere around here would be good. Now, your telescope could have many additional features in addition to the ones I've already mentioned. Like it could have a way of finding the things you like to look at, which would be a very important feature. I would personally recommend something like a telrad, like this. It's a little box that puts a target on the sky, and it's really easy to find things because you just use your phone. It tells you where the thing is in the sky, and then you push the telescope around till the little target is in front of the thing you'd like to look at. Very easy to use. I've taught a kid that was in preschool how to use it in about 5 minutes. And he was quickly going to Jupiter, going to Saturn, just going back and forth between them, and he was having a ball. So I would definitely recommend a telrad. It makes things very easy. I usually don't recommend go-to capability for beginners because with go-to, they have a lot of trouble setting it up, and it causes problems because they don't actually learn the sky. It's better to do this, I think. But when you get more advanced, when you're doing, say, astrophotography like I do, then go-to becomes a lot more useful because then you can sit at your computer, tell the machine to slew to whatever you'd like to go to, and then remotely controlling from your computer, tell it to image what you'd like to image. So that go-to capability, I think, should come a little later. Tracking capability can be kind of nice because you can actually track the object as the Earth rotates and it goes across the sky, so you can stay with the object. A really basic Dob is not going to be able to do that. One of the more expensive telescopes like these can do that, but again, they require more setup. So I usually would recommend tracking if you're doing an outreach event and you got a whole bunch of kids that are standing in line waiting to look through a telescope. It's nice to have it keep going on the object, keep tracking the object so you don't have to keep moving the scope. But for a beginner, I usually don't recommend that because it's more trouble than it's worth. I usually just recommend having a telescope that you can just push to the object and look at it. The computer control and go-to and tracking, that's more advanced, costs more money, and really isn't for beginners, I don't think. So should you rush out and buy a telescope now? I wouldn't recommend it, actually. What I usually recommend that members do when they join our club and say, ooh, what telescope do I buy? I say, wait, slow down. We have telescopes you can borrow. If you're a club member, you can borrow one of our Dobsonian telescopes. Or if you're interested in, say, a Schmidt-Cassegrain, or if you're interested in a refractor, you can borrow one of those. See how they work. You can check out some of the club members' scopes, because our club members, you know, we have over 100 club members. You might want to look through some of their scopes. They're usually more than willing to let you have a peek. And you can ask them questions about it, say, what do you like about your telescope, learn a little bit about it, see what you're interested in doing. I can tell you that depending on what you want to do, like what you want to observe, whether you'd like to take pictures of the night sky like I do, or whether you just like to look with your eyes, it really determines what telescope you should buy. So I usually recommend try some things out, do some research, go to a star party or two with a club, ask people questions, and find out what it is you'd like to do before you spend lots of money on a telescope. And by the way, this is a star party picture during the daytime, of course, not the nighttime, but this is the same star party at night. And these people are climbing up a ladder to look through a very large Dobsonian telescope. So you have a telescope or you have binoculars, and you'd like to find some of these things I've been talking about. You want to find a cluster. You want to find a galaxy. You want to find a nebula to look at. You're really excited with your new telescope. So what I usually recommend is use your phone, like an app on your phone. So I'm going to open one now. And in the app on your phone, it'll show you constellation patterns as well as the objects I was mentioning in those constellations. So if I scroll around here, I found the constellation of Hercules here. And if I zoom in a little bit, oops, it just bumped it right. There we go. If I zoom in a little bit, I'll see that there's an object right there. Oh, it did it again. Sorry. I can't show you and look at it at the same time. Try that one more time. So the object I'd like to look at is right about there. And you can use the phone as a guide to help you look through the binoculars at the right spot, or use the telrad to point the telescope at the right spot. And you can look at the object. Likewise, you could get an atlas like this, and you could look up the particular thing you'd like to look at. Let's say you'd want to see the Pleiades, like we looked at earlier. So if you note in the little atlas that here's Taurus the Bull, and there's this nice pattern of stars here, you can use the pattern to locate the Pleiades, which is right there. So you can use this to find that. It's like a little treasure hunt. It's actually kind of fun. If you get a go-to scope, you don't get to have that fun. I think it's personally very fun. And if you're interested we could show you how at some event this summer. But you can use those constellations to help you find it. We call that process star hopping to find the objects. You can use a go-to telescope, but again, it does take a little setup to get it all ready to go. The guidebook, like I was showing you, is actually very helpful. There's also these finder charts. We have them in our club. We keep them in our observatory. I don't personally own those, so I can't show them to you right now, but they're actually very nice for beginners. We call them the Telrad finder charts. The software on the phone, there's a couple of different apps on your phone that work quite well. Now, I won't recommend one that's paid. I don't know if I have it on my phone right now. The one I usually, oh, there it is. The one I usually recommend to folks is Star Chart, because it's easy to use and it's free. Just a second. It's fairly easy to use and it's free. And it does this nice thing, of course, where you point it up at the sky with your phone and it'll tell you what constellation you're looking at. And it's the same app, whether you're on an Android phone or an iPhone. So that's usually the one I recommend. It's called Star Chart because it's fairly easy and it's free. It's not the one I usually use, but it works very well and it's great for beginners. So that's the one I usually recommend for them. I will tell you one thing that's very important. If you are going to use your phone at a dark sky site, you should get some red film to cover it up. Or there's a neat trick you can do on an iPhone where you can configure an accessibility shortcut and turn the whole phone red like that. So that's what I tend to do. It's a little trick that you can use. We actually posted on our website how to do that. It's a nice trick. But if you don't have that, you should definitely cover it with red so you don't ruin your dark adaptation. You want to get your eyes accustomed to the night sky so you can actually see the things you'd like to see. Likewise, you should get a red flashlight or cover the front of your flashlight with a red film so that you don't ruin your night vision so you can actually see at night. It takes about 5 minutes of darkness for you to fully dark adapt. I'd also like to talk really briefly about some of the objects you might like to see. Charles Messier, who was a comet hunter in the 1700s, was interested in finding comets so that he could be remembered for it, because if you found a comet, you could name it. And so he wanted, Comet Messier. But the thing is, what he's remembered for today is not the comets that he found. He made a catalog of all the things that were not comets that he ran across so that other people wouldn't be led astray by these fuzzy looking objects that weren't actually comets. So he made a catalog of over 100 objects that were not comets. So they were things you weren't supposed to look at because they weren't comets. But it turns out that his list of bad objects that you shouldn't look at are the best objects to look at in the night sky with a small telescope, or with a camera, if you want to do some pictures, or even with binoculars. So definitely a good list. So his list of objects, you can find them on the internet. You can find them in those apps I was telling you about, like in Star Charts or other apps. You'll see the Messier objects labeled on the chart. And definitely worth checking out. Let's say you're interested in taking some photos. I am an astrophotographer. I do a lot of astrophotos, like the picture that's right behind me here of the Pleiades, and a bunch of pictures that I've been showing you throughout this presentation, and the picture that I'm showing you right here, in fact. So question might be, how do you start taking astrophotos? Well, I'll tell you, it's fairly simple. Literally, you can just take your DSLR that you have maybe lying around for taking pictures in the daytime, and you can put it on a tripod, set it to take an exposure of maybe 30 seconds, and you'll get an image of the stars in the sky. it might not be the image you were hoping for. You might have to make some changes, like for instance, increasing the gain or ISO value will definitely help. Maybe increasing it to about 1600 is usually a good idea at least. And you'll find it gets a lot brighter and shows more deep sky objects. But you can get good images of the Milky Way and some deep sky objects with fairly short pictures of less than a minute. Now, if you do that, you don't want to be zoomed in like this, because if you do that, you're going to get horrible trailing, because remember that the Earth is spinning. And as it spins, it'll blur your photos as the stars fly through your view. So I would recommend zooming out or using a different lens so that you can get good images where the stars are not too blurred. Now, if you would like to improve that even further, you don't like these trailing stars, and you'd like to pick up the Milky Way like this, but you don't want it to be blurred like that, you can get a device called a star tracker. And there's several different ways you can do this. There's little barn door trackers you can build yourself. You can buy one like this. There's a variety of ways that you can get one of those. And basically what it does is it just turns the camera with the night sky. And so you can take 5-minute, 10-minute exposures, depending on how good your tracker is, and they come out fairly good. And you can get beautiful images of the Milky Way. The pictures I showed you earlier, like back here, we're taken with a star tracker, like the one I had in my hand just a minute ago. Just a second, sorry. Here's some of those things. The one I was just holding is right here. Here's one that you can build yourself. Here's a different model right there. Or you could strap it on the back of a telescope that tracks the sky, and that works too. So there's a variety of ways you can take photos like that. And it's fairly easy. But what if you want to shoot things like what's behind me right here, the Pleiades, or let's say you want to shoot the Andromeda Galaxy or some other cool thing like that. Well, for that, you're probably going to need to hook it up to a telescope or a longer focal length lens. So you need a better camera lens or a telescope. I would recommend a telescope. You'll get better images because there's more light. So you can actually get little attachments for your camera so that you can put it on the back of your telescope. And if your telescope tracks the sky, you can get decent photographs. Now, you've got to work at that, and there's all kinds of things you can do to make them better, but you can get really basic photographs of the night sky through your telescope for like maybe 30 seconds. You can't do a 5-minute exposure and expect it to come out good by just doing that. There's more involved, and that's beyond the topic of this discussion right now. But if you're interested in taking photos like this, which are photos that I took, here's the device that I used to take those photos. It's a telescope that I put together. We can help you out. You can join our club, or you can ask me questions, and I can certainly help you to take better photos if you're interested. So if you don't like the telescopes that you can find in the stores, you could actually make your own telescope. This is a telescope that I built about 7 years ago now, I think it was. And this telescope that I built, I ground the mirror by hand, and I constructed the telescope from an irrigation pipe. And I built the mirror cell to hold the mirror in the back and the secondary holder to put up in the front. And I even built the Dobsonian base that you see right here. And we can help you to do that in our club as well. So really, I think the most important thing you can do if you're getting started in amateur astronomy is join a club. We have the Delaware Astronomical Society, which I'm the president of. We also have the Chesmont Astronomical Society, who's to the northwest of here, and the GVAA, Delaware Valley Amateur Astronomers, to the northeast. And there's several other clubs a little further away if you have interest and you're a little further away. But in a club, You can borrow gear. You can talk with others, who have already gotten experience using the things you'd like to do. You can get all kinds of educational presentations. You can go to outreach events the club is doing and participate in them. You can go to the star parties. You get all kinds of free assistance. You got a nice social atmosphere. You can make friends there. You got an astrophotography group or a book group if you're into those things. So there's lots of different things you can do in a club that you can't do by yourself. And I have some images here of some different events that we've done. And you can see these are some of our club members. This is at Mount Cuba. We're testing some telescopes here. This is our club observatory using some of our club equipment. This is at one of our outreach events. I think this is the same event at Chesla Nature Preserve. Here's a bunch of kids coming to that outreach event and looking through a telescope and looking at the sky to see what they were looking at in the telescope. Here's somebody using binoculars to look at the sky. Here's a Woodside Creamery event. You can see people using the scopes there and people coming up, asking us questions, looking through these telescopes. And here were some fairly new members a couple of years ago learning how to use the equipment on a nice evening. And you can see another outreach event here. I believe this is probably Archmere Academy. I think this is at Woodside Farm Creamery, as is that. And I think that might be as well. But yeah, you can do all kinds of things in a club, a lot more than you can do just on your own. So we can help you out in your interest in amateur astronomy.